Hello, today we will be determining what makes a function even or what makes a function odd. Understanding if a function is even or odd will help aid in comprehending the properties of graphs and what to expect from functions. If we're looking at what an even function is and we're given the function f of x, then it's considered even if you plug in a negative x within the function f of x and you are left with your original function f of x. Similarly, looking at an odd function, if you're given the original function f of x and you plug in negative x for all x's, and your function produces a negative f of x, then you know that it's an odd function. It's also important to note that when looking at even and odd functions, you're able to determine a few properties. If it's an even function, then the graph is symmetric to the y-axis. That indicates that if you have a graph, for example, something that looks like this, and it's an even function, then it's going to mirror about the y-axis. Similarly, if you have a odd function and the graph looks something like this, then it's symmetric around the origin, which means it will look like this. And if f of negative x does not equal f of x, and if f of negative x does not equal negative f of x, then the function is neither even or odd. So again, if this property doesn't hold true and or this property doesn't hold true, then you do not have an even and or an odd function, which is not a problem, but then we're not able to visualize the graph as easily. But let's look at a couple examples of what a couple even functions and what a couple odd functions are. Okay, looking at our first problem, we have the function f of x equals 5x cubed plus 2x, and the question asks us to determine if this function is even and or odd. With that, we know that it's an even function if you insert a negative value within f of x, and you're still left with f of x. We know it's an odd function if you take the negative value of x and put that into the function, and you're left with a negative function. Then we know it's odd. What we need to do then is just substitute in a negative x value into this f of x and determine what we're going to get. If we put in a negative x, then we are going to be left with 5, and then that's a negative x, and that's cubed, plus 2 times negative x. When we simplify, we know that negative x cubed is still equal to a negative x cubed, so we bring that negative out in front, and we have the 5x cubed, and then 2 times negative x is equal to a negative 2x. And if we want to, we can bring out that negative because that's the same in both terms, and we're left with 5x cubed plus 2x. And this answer would tell us that if given the function f of x and you're putting in a negative x, then we're going to be left with a negative f of x. When we look at this rule, we see that it's an odd function, and therefore we know this function then is odd. The tricky part about this one is just that negative x cubed, and you just have to remember that this is really a negative 1 multiplied by x, and then this is cubed. When you distribute this power of 3 in, you get a negative 1 cubed multiplied by x cubed, and this is really equal to negative 1 times negative 1 times negative 1 is negative 1 multiplied by x cubed. And then we multiply that by 5, and that's how we're able to get that negative 5x cubed in that first part. So just be careful for that. Okay, let's look at another example. Looking at our next problem, we have the function f of x equals the square root of x squared plus 4. And the question asks us to determine if this is an even or an odd function. Again, with our rules, if it's an even function, if we do a negative value within x and we're given our original function, f of x, then it's even. And similarly, if it's an odd function, if we put that negative value of x in there and the output is the negative of our original function, then it's an odd function. When we substitute in a negative x, then we're going to be given the square root of negative x squared plus 4. When you simplify, you're going to be left with the square root of x squared plus 4. And this is the exact same as our original function, and therefore this is an even function. We also want to note that if we graph this, it's going to be symmetrical with respect to the y-axis. And in our last example, because it was an odd function, it would have been symmetrical with respect to the origin. Again, something to keep in mind if you are asked to graph this or to determine a couple of the properties of the graph, you'll be able to deduce that from determining if it's an even or an odd function. All right, let's look at one more example. All right, looking at our final example, we have the function f of x equals 8x cubed minus 3x squared. And again, the problem asks us to determine if this is an even or an odd function. Writing out our rules, we know it's even if f of negative x equals our original function of x. And we know it's an odd function if we put in the negative x value and we're left with a negative multiplied by our function. When we plug in negative x into the function, we're going to get 8 multiplied by negative x, and then cubed minus 3 multiplied by negative x, and squared. When we simplify, we're going to get negative 8x cubed minus 3x squared. If we factor out that negative sign, then we're left with 8x cubed plus 3x squared. And what we see is that f of negative x does not equal f of x, our original function. We also know that f of negative x does not equal our function multiplied by negative. And therefore, this function is neither even or odd. And this just tells us that we do not know the properties of the graph. We do not know if it's symmetric with respect to the y-axis, or we don't know if it's symmetric with respect to the origin. We cannot determine any properties about this graph just given the properties of even and odd. And there you go. Now you understand and can identify if a function is even or odd. This knowledge will allow you to think about what the graph should look like if you choose to sketch the given function, and then use it as a check reference utilizing the symmetry properties that are associated with even and odd functions. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.